Okay, this video has examples for the study island topic, factor and solve polynomial equations. So let's get into it. First one is 1/2 times x squared plus 5/2 times x plus 31/8 equals 0. So we're going to solve this. First things first, it might be easier if I just got rid of all these fractions. So I'm going to multiply everything in this equation by 8 because that's the lowest common multiple of all my denominators. So I'm going to say 8 times 1/2 x squared. 8 times 1/2 is 4, so it becomes 4x squared. And then we have 8 times 5/2, which is 20x. 8 divided by 2 is 4, times 5 is 20, so plus 20x. And then 8 divided by 8 is 1, times 31 is just plus 31. And that equals 0 times 8, which is still 0. So now I have another quadratic equation, but this time it is just whole number coefficients rather than fractions, and that makes it a little easier. Now, when you get a quadratic equation, there are multiple ways that you can solve it. The three methods we use for solving quadratic equations are factoring. We can factor this trinomial into the product of two binomials, and then if the product of two binomials is 0, then the solution is whatever makes each one of those binomials worth 0. Because if we have the product of two binomials equal to 0, that means one of them must be 0. In other words, if I'm multiplying together two things and the answer is 0, one of the two things I'm multiplying has to be 0. So if I can factor this into the product of two binomials, that will help me solve it. Another way that we can solve this problem is called completing the square. I can complete the square. Sometimes it's easier, sometimes it's a little trickier. But completing the square is another way that we can solve a quadratic equation. And then the last one is called using the quadratic formula. Okay, so the quadratic formula is the universal that always works for any quadratic equation. And when I say that, I mean any equation that's in the following format. A times x squared plus b times x plus c equals 0. If you have something that is in that format, then you can use the quadratic formula to solve it. I'll tell you what the quadratic formula is in a moment. But this is in that format. A times x squared. In this case, a is 4 because this is 4 times x squared. So in this equation, our a is 4. B times x. Well, it's 20 times x, so b is 20 in this case. And c is 31. So in this equation, a is 4, b is 20, and c is 31. And we can use the quadratic formula. What is the quadratic formula? The quadratic formula is this. If you have a times x squared plus b times x plus c equals 0, then x will always be equal to negative b plus or minus the square root of b squared minus 4 times a times c divided by 2 times a. This will always work. It won't always be the most convenient. It won't always be the quickest way to do it, but it will always work. So let's go ahead and plug these numbers in to this formula and see what we get out. It looks a little bit intimidating if it's the first time you've seen it, but once you use it enough times, it gets pretty routine. There's not too much to it. So let's go ahead and figure this out. X equals negative b. B is 20, so we have negative 20 plus or minus the square root of b squared. So we have 20 squared minus 4 times a, which is 4, times c, which is 31, divided by 2 times a, which in this case is 2 times 4. So all we have to do is now simplify this quadratic equation, and we will keep getting our answer. So what's the next step? X equals, well, negative 20 is just negative 20, plus or minus the square root of 20 squared is 400, minus 4 times 4 is 16, and 16 times 31. Don't be afraid to go ahead and use a calculator for this. 16 times 30 is 480, so 16 times 31 is 496. And so we have minus 496. And then divided by 2 times 4 is 8. So there we go. We're just going to keep going. X equals negative 20 plus or minus the square root of 400 minus 496 is negative 96 is divided by 8. Now, if you don't know what to do with this, if you're not sure, you need to go back and double check your complex numbers topic. If you need a video on that, let me know, because I have one already made up that goes through complex numbers and how you get the square root of negative numbers and things like that, and how you write it. So ask me for that link if you want it, and I will give it to you. Let's do our next step here. We have x equals negative 20 plus or minus. We'll break down the square root of 96, of negative 96. First, I'm going to say the square root of negative, well, that was much too long. The square root of 96 times the square root of negative 1 divided by 8, because I'm going to break out that negative symbol. That square root of negative 1 from now on will just be I. So now I have x equals negative 20 plus or minus, and 36, 25, 4, what goes into 96? 96 divides by 4. And again, you're checking for, if you haven't seen this before, you're checking for factors of 96 that are perfect squares. So the only things you don't want to divide this by 2 or something like that. You want to divide it by a perfect square. So you're looking to see if 96 divides by 4, by 9, by 16, by 25, by 36, by 49, etc., etc., etc. So which of these are factors of 96? That's what you're trying to figure out. 96 divides by 4, clearly. 96 divides by 4 24 times, but 24 also divides by 4, so that means 96 divides by 16. And of course, you have plus or minus square root of 16 times the square root of 6 times the square root of negative 1, which again, we're just going to call I. So instead of writing times square root of negative 1, I'm just going to write times I. So again, 16 times 6 is 96. So I can write the square root of 96 as the square root of 16 times the square root of 6. And again, this is all being divided by 8. So let's just keep moving along. X equals negative 20 plus or minus. The square root of 16 is just 4. So I have 4 times the square root of 6 times I divided by 8. And now I can divide negative 20 by 8 and my 4 by 8, and I'm done. Negative 20 divided by 8, they would both simplify by a factor of 4. Negative 20 divided by 4 is negative 5 plus or minus 4 divided by 8 would be 1 times the square root of 6 times I divided by 2. Okay, so we just divided 4 out of both of those. Negative 20 divided by 4 is 5, and 4 divided by 4 is 1, and 8 divided by 4 is 2. So now an easier way to write this, we don't have to write the 1. We just simply say negative 5 plus or minus the square root of 6 times I divided by 2. So this is actually 2 answers. It's negative 5 plus the square root of 6I divided by 2, and negative 5 minus the square root of 6I divided by 2. Another way to write it is we could break this up into 2 separate numbers. So I could say negative 5 over 2 plus or minus the square root of 6 times I over 2. That's another way to write the exact same thing. So this is our answer. We have 2 of them. And let's see if that's one of them over here. Where's my mouse? There it is. So that's negative. The only one that starts with negative 5 halves is right there. And sure enough, plus or minus the square root of 6 over 2 times I. It doesn't matter if this I is in the numerator or if it's out next to it, making the square root of 6 over 2 as a coefficient. It's the same thing. Okay, let's go ahead and do another one. X squared plus 49. Which of the following is equal to the polynomial given above? This problem relies on your knowledge of one simple fact when it comes to multiplying binomials together and factoring binomials, and it's this. You need to understand the difference of 2 squares. Anytime you have 2 things that are squared together and you're subtracting them, you can break that up into 2 binomials that look like this. The square root of a squared is a, and the square root of b squared is b. You take the square root of both. One binomial is those 2 things added together, and the other binomial is the 2 things being subtracted. So a plus b and a minus b, that's how it works. So if you have 2 squares that you're subtracting, you can break it up into the sum and the difference of the 2 square roots. Why does that work? Well, because if I'm multiplying this binomial times this binomial, I have to multiply both of these terms by both of these terms. So let's just do them one at a time. What's a times a? A squared. What's a times b? Well, in this case, negative b. Negative ab. And then I have plus b times a. So plus b times a, which is the same thing as a times b. And then positive b times negative b would be negative b squared. And of course, negative ab and positive ab would cancel each other out. They would zero each other out, and you're left with a squared minus b squared. So you have to remember that rule, a squared minus b squared. The difference of two squares in that pattern is used all the time when we're factoring polynomials. Now you might be looking at that going, Fager, what are you talking about? That's not the difference of two squares they gave us. That's the sum of two squares. It says x squared plus 49. And you're absolutely right, but maybe we can do a little bit of trickery to turn this into a difference of two squares. What am I talking about? I'm talking about the fact that I squared is equal to -1. Again, if you're not up to date on your complex numbers, if you're not sure why I squared is equal to -1, I'll send you another video, but just remember that I is equal to the square root of -1. So if you square it, you get the square root of -1 squared, which is just -1. So what I'm going to do is I'm going to say x squared minus 49i squared. Now let's look at what we just did there. I changed this from plus 49 to minus. Why was I allowed to do that? Because I'm multiplying 49 by I squared. Well, 49 times I squared is 49 times -1. 49 times -1 would just be -49. So I'm subtracting -49. And if you're subtracting a negative, that's just the same as adding. So again, if I make 49 into 49 times I squared, that's the same as making it into 49 times -1, because I squared is -1. If I have 49 times -1, that's -49. Since I actually want plus 49, I have to subtract the -49. But the way it's written now, it's written as the difference of two squares. So I can break it up into the product of two binomials, x plus, and then what's the square root of 49i squared? 7i. So x plus 7i and x minus 7i. That is the product of two binomials that is equal to x squared plus 49. So then we go over here and we take a look for it, and x plus 7i and x minus 7i. There it is. Okay, here's another one. X squared plus 144 equals 0. This is basically the exact same thing we just did. We're taking the sum of two squares, and we're going to turn it into the difference of two squares. So x squared plus 100, just 44 instead of 144. X plus 144 equals 0. I can factor that into, well, let me turn it into this first. X squared minus 144 times I squared equals 0. So this is, again, the exact same thing, because I squared is -1. 144 times -1 is -144. Subtracting -144 is the same as adding 144. Now I can use my pattern of breaking down the difference of two squares, and I can say the square root of x squared is x. And the square root of 144, I squared, is 12i, because 12 times 12 is 144, and I times I is I squared. So x plus 12i, and then I have x minus 12i, and that would equal 0. And so now, what is going to make each one of these things equal to 0? I have the product of two binomials equal to 0. If I have the product of two things, and again, product means the answer to a multiplication problem. If I have the product of two things, this thing in this parentheses and this thing in this parentheses, this binomial and this binomial, the product of those two binomials equals 0. That means one of them has to be 0. So the answer to this equation is whatever makes either one of these 0. So let's start with this. X plus 12i. Well, the only thing that's going to make that 0 is if x was -12i. -12i plus 12i makes 0. And similarly, over here, the only thing that would make this 0 is if x was +12i. Because 12i minus 12i is 0. So those are the two answers to our equation, positive and -12i. And that's what this says right there. Another way to do this equation, this may have been overcomplicating it a little bit. Let's just say we had x squared plus 144 equals 0, and we just subtracted 144 from both sides. that would give me x squared equals negative 144. And then I take the square root of both sides. The square root of x squared equals the square root of negative 144. And again, if you haven't seen problems like this, make sure you go back and ask me for my complex number and I video. But you want to make sure you say it's the positive or negative version of the square root of negative 144. Whenever you take the square root in an equation like this, you must include the positive or negative version of your square root. The square root of x squared is x, and that is equal to positive or negative square root of 144 times the square root of negative 1. And that means x is equal to positive or negative square root of 144 is 12, so positive or negative 12 times square root of negative 1, and the square root of negative 1 is I, so positive or negative 12i. That is another way to do the exact same problem and come up with the same two answers, positive 12i and negative 12i. All right, let's go another one. 4x squared plus 9. This is, again, the difference of two squares problem. We're returning the sum of two squares into the difference of two squares. So let's do another one. 4x squared plus 9. I'm going to go ahead and turn that into 4x squared minus 9i squared. Okay, I squared is negative 1. So I'm just going to go ahead and pretend that this is minus negative 1, or excuse me, minus negative 9, which turns into plus 9 like we have. And now it's the difference of two squares. The square root of 4x squared is 2x, so it's 2x plus the square root of 9i squared is 3i, so 2x plus 3i, and then 2x minus 3i. Okay, so which one says that? 2x plus 3i, 2x minus 3i. Solve for x. This is just a straight up quadratic equation. We've got x squared plus 6x plus 44. So x squared plus 6x plus 44 is equal to 0. And again, this follows our format of ax squared plus bx plus c equals 0. So we can definitely use the quadratic formula for this. We can use the quadratic equation. We don't necessarily have to. You can try and factor this down. What multiplies to be 44 and adds together to be 6 would be the question you're trying to ask yourself, and it's difficult to do those, so feel free to just use the quadratic formula on these. A is equal to 1 in this case. Remember, this is 1x squared. B is equal to 6, and C is equal to 44. So here we go. X is equal to, again, negative b plus or minus the square root of b squared minus 4 times a times c divided by 2 times a. Got to just remember that. You will have to prove it in high school. When you get to that point, you're going to have to actually do all the steps that you would take to get from this to this. But for now, you should just memorize it. All right, let's go ahead and plug in our numbers. We've got x equals negative 6. That's the ugliest 6 I've drawn in a while, but oh well. Plus or minus the square root of 6 squared minus 4 times 1 times 44 divided by 2 times 1. All right, so x equals negative 6 plus or minus the square root of 6 squared is 36 minus 4 times 1 is 4, and 4 times, you can't even see that, I'm sorry. So start that again. Negative b plus or minus the square root of b squared minus 4 times a times c divided by 2 times a. All right, so negative b. Negative 6 is just negative 6 plus or minus the square root of b squared, which is 6 squared in this case, which is 36. And now we're doing 4 times 44 because we want to do 4 times 1, which is 4 times 44. And 4 times 44 is 176. So minus 176 divided by 2 times 1 is 2. So now x equals negative 6 plus or minus the square root of 36 minus 176, which is negative 140 divided by 2, I should say equals. And now x equals -6 plus or minus, what can we break up 140 into? That's a perfect square. So again, you're looking for factors of 140 that are perfect squares. Perfect squares, 4, 9, 16, etc., etc. If you're looking for just regular factors, it's not going to work. I get students all the time that want to divide this by like 2 or something like that. You can't divide it by 2. It's not going to work, okay? So 140 divided by 4 is 35. So you're going to have the square root of 4 times the square root of 35 times the square root of -1, all divided by 2. And here we go. X equals -6 plus or minus, square root of 4 is 2, so 2 times the square root of 35 times I, because the square root of -1 is I, divided by 2. And so you have -6 divided by 2, which is -3, plus or minus 2 divided by 2 is 1, so it's just square root of 35 times I. And there's your answer. Now, again, 35 breaks up into factors like 7 and 5, but those aren't perfect squares, so it doesn't matter. You're good with these. That's all you want there. You don't need anything else at that point. If you have the square root of 35 times I, it can also be written, and probably should be written, as I times the square root of 35. Just makes it a little bit easier to read, putting the I in front of the square root symbol so that there's no confusion if the I is under the square root symbol or not, like square root of I, which is not something you would have, but you get my point. So -3 plus or minus the square root of 35 times I, or I times 35, which is that one there. Okay, select piece of paper. Select all the correct answers. What are the roots of the following equation? The roots are the things that make this equation worth 0 when you plug in x. So basically, we're just solving for x here. Nothing is different. Now, you could go ahead. They give you a bunch of choices here. So you can go ahead and just plug each one of them in if you want, or you could just solve this and choose all the answers individually. It's kind of up to you. I would like to, in this case, usually factor out my answers. You can actually plug this into the ax squared plus bx plus c equation, sort of. It's a little bit trickier than normal, but you could do that. But probably the best method here is to factor. So let's go ahead and write this down. We got 4x to the 4th minus 35, x squared minus 9 equals 0. So how can we factor this? We have 4x squared minus 35x minus 9 equals 0. Well, basically what you're going to figure out is that you can break this down into the product of two binomials again. And to figure out which ones you can break it down into, there's different methods to do it, but the bottom line is that the beginning of this have to multiply to be 4x to the 4th power. So it's going to be something x squared and something x squared. It might be either 2x squared and 2x squared, or it could be 4x squared and 1x squared. And at the end of this, you've got to multiply to get 9. So it either has to be 9 and 1 or 3 and 3. So you're trying to figure out what combination of 2 and 2 or 4 and 1 multiplies with either 9 and 1 or 3 and 3 to make -35. And again, one of these has to be positive and one of them has to be negative because you have -9. The only way to multiply two things together to get -9 is to have one is a positive and one of them is negative. So if you have 3 and 3, one of them is going to be positive 3 and one of them is going to be -3. If you have 9 and 1, one of them is going to be positive and one of them is going to be negative, but it's hard to tell exactly which until you look at your middle number, because when you multiply either 2 and 9 and 2 and 1 and add them together, you have to get -35. That's not going to happen with any of these, okay? You can't do 2 times 9, which is 18, and 2 times 1, which is 2, and somehow end up with -35. You also can't do it with 2 times -3 and 2 times -3. You can do it with 9 times 4, which is 36, and 1 times 1, which is 1. 36 minus 1 is 35, or negative 36 plus 1 is negative 35. So what you've got here is 4x squared and 1x squared, and you want to multiply 4 times 9, so that's going to be in the other binomial. So you've got minus 9 over here because you wanted it to be negative 36x 36x squared plus 1. So 4x squared plus 1 over here, and x squared minus 9 over here. So just to double check and make sure we understand why that worked out, 4x squared times x squared is 4x to the fourth. 4x squared times negative 9 is negative 36x squared. 1 times x squared is 1x squared. Combine that with our negative 36x squared, and we have negative 35x squared. And then finally, 1 times negative 9 is negative 9. So now we can solve this. Again, this is the product of two binomials, but I can actually break this up a little bit more because this is the difference of two squares. So I'm going to break that up, and I can turn this into the difference of two squares by making it 4x squared minus I squared. Again, I squared is negative 1. So I can break that up. So now I have two different differences of two squares. So 4x squared minus I squared, I can break that up into 2x minus I times 2x plus I. And over here, that would be x plus 3 and x minus 3. And all that equals 0. And now we have 2x times 2x, which is 4x squared, and we have 2x times I, which is 2xi, minus I times 2x, which is minus 2xi. So those cancel out, and then negative I times I, which is negative I squared, so on and so forth. So the bottom line is now I have 4 different binomials that when I multiply them together, I get 0. So my answers are all the things that make either one of these 0. So let's start from the easiest ones to the harder ones. What makes that 0? Well, if x is 3. So that's one of our solutions. Let's find it. X is 3 right there. Okay, what makes this binomial worth 0? If x was negative 3. Those ones are pretty simple because you just do the opposite of what's there. So if x is negative 3, that's this answer. Okay, what makes this 0? Okay, well, that one's a little bit trickier. Let's write it out. 2x plus I equals 0. So I subtract I from both sides, and I get 2x equals negative I. And then divide by 2 on both sides, and I get x is equal to negative I divided by 2. That would also be written as negative 1/2 times I, because that's 1I divided by 2. So where is that answer? Where is negative I divided by 2? That's right there. And then this is the exact same thing, except you wouldn't have negative I on the right side. It would be positive I, because you would have 2x minus I equals 0. You would add I to both sides, and you get 2x equals I, and then divide by 2 on both sides, and you get x equals I divided by 2, or just 1/2 I. And where's that answer? I divided by 2. So there are 4 roots. Those are the 4 solutions to this equation. And yeah, let's keep moving. All right, let's come back for another one here. What are all the roots of x to the 4th plus 24x squared minus 25 equals 0? So a very similar type of problem. We are going to do x to the 4th power minus 24 times x squared minus 25 equals 0. And then again, if we're going to factor this, we're going to factor it into the product of two binomials is equal to 0. And we're going to figure out, well, x to the 4th, that's got to be x squared times x squared in this format. Okay, so you've got x squared times x squared. The only other thing that you would do is that you would have x cubed times x, but then what happened to the x cubed? You would have x cubed times something else and nothing else to eliminate it with. So the only way you're going to get x to the 4th power and then x squared with no x cubed and no x is if it's x squared and x squared. So now all you have to do is figure out what multiplies to be negative 25. So it's going to be 1 positive and 1 negative. What multiplies to be negative 25 and adds together to be negative 24? Well, it's going to be negative 25 and positive 1. It's the only two factors of 25 that are 24 apart. So now I have x squared plus 1 and x squared minus 25. And this, just like the last problem, is the sum of two squares and the difference of two squares. So I will turn my x squared plus 1 into x squared minus I squared, because again, I squared is -1, so minus -1 is plus 1. And then I have my x squared minus 25. And now I can break those up into two sets of differences between two squares. So here we go. The first one, x squared minus I squared, becomes x plus I times x minus I. And then x squared minus 25 becomes x plus 5 times x minus 5. So again, we've got four binomials, the product of which is equal to 0. So the answers for each of these is whatever makes each binomial worth 0. So this, what makes it 0? If x is 5. What makes this 0? If x is equal to -5. What makes this one 0? If x is equal to positive I. And what makes this 0? If x is equal to negative I. These are your four answers. I, negative I, 5, and -5. That says -1 and +1. That's not what I want. I want -5, +5. Okay, where did we go wrong here? Pause for a second. Okay, I just saw my mistake and I want to show it to you so that you don't make the same mistake. Dumb mistake. It doesn't say in the problem x to the 4th minus 24x squared. It says x to the 4th plus 24x squared. So you probably saw me doing this problem in the beginning. If you notice that I made that silly mistake, then good for you. It should be plus 24x squared. That changes some things. -25 is what we want, but we want to have 24x squared left over. So it's still going to be 1 and 25, but the 25 is positive and the 1 is negative. So it's going to be x squared minus 1 and x squared plus 25. That will change our difference of two squares. I don't want it to be minus I squared anymore and x squared minus 25. I'm going to change a couple things. So let me just start this over so it's real clear. Go back down here. We've got x squared minus 1 and x squared plus 25 are equal to 0. So this is already the difference of two squares. The square root of x is x and the square root of 1 is 1. So that's going to be x plus 1 times x minus 1. And I'm turning this into x squared minus 25 times I squared. So again, minus 25 times I squared, because I squared is equal to -1. 25 times -1 is -25, minus -25 is plus 25. So now I have my x plus 1 times x minus 1 times x plus 5i times x minus 5i equals 0. And like before, our answers are all the things that make each of these binomials 0. So we've got x could be -1, +1, -5i, and +5i. And that's the one we clicked on. Here we go. All right, let's do another one. -25x squared plus 10x minus 3 equals 0. So you can factor this one, or you could try to factor it. But again, I would just, if I were you, go with the quadratic equation. The more you do it, the easier it gets, and you don't have to guess as to whether something can be factored or not. You're looking for, 5x times -5, something like that. It gets pretty hairy, especially if the very first term that you're looking at is not a perfect square. So just use the quadratic formula. Again, the quadratic formula is that x is equal to -b plus or minus the square root of b squared minus 4 times a times c divided by 2 times a. For any equation in which you have a times x squared plus b times x plus c equal to 0. So let's go ahead and figure that out. Our a, in this case, is negative. It's -25. So a is -25. B is 10. And c is -3, because we are subtracting 3 right there. So here we go. X is equal to -b, which is 10, plus or minus the square root of b squared, which is 10 squared, minus 4 times -25 times negative 3 divided by 2 times a, which is negative 25. So next, x equals negative 10 is just negative 10 plus or minus square root 10 squared, which is 100, minus 4. So I think of this as negative 4 times negative 25, which is positive 100, but then times negative 3 is negative 300, so minus 300, divided by 2 times negative 5, which is negative 50. So then we have x equals negative 10 plus or minus the square root of 100 minus 300, which is negative 200, divided by negative 50. And here we go. X equals negative 10 plus or minus. Now again, we're breaking negative 200 up into hopefully perfect squares. I'm going to make it the square root of 100 times the square root of 2 times the square root of negative 1. Because 100 is a perfect square, and we're dividing that by negative 50. So here we go. X equals negative 10 plus or minus the square root of 100 is 10 times the square root of 2 times I. So the square root of negative 1 is I, all divided by negative 50. And then I can divide negative 10 out of both of those. So that's going to be negative 1 plus or minus 1 times square root of 2 times I. So I'm going to call that I root 2 divided by negative, divided by 10. So that's negative 5. Now, negative divided by negative is a positive, and that is positive and negative both. So this is actually going to turn out to be just 1 over 5 plus or minus I root 2 over 5. And yeah, that's our answer. So which one is that? Which one is 1 plus or minus I root 2 over 5? 1 plus or minus I times the square root of 2 over 5. There's that one right there. So another one, what are all the roots of 4x squared plus 9 equals 0? This is like one of the problems we did in the beginning where we turn the sum of two squares into the difference of two squares. So here we go. We got 4x squared plus 9 equals 0. So I can turn this into 4x squared minus 9i squared equals 0. And so now it's 2x plus 3i times 2x minus 3i equals 0. And now I just have to figure out what makes each one of these worth 0. So first I'll try 2x plus 3i equals 0. Subtract 3i from both sides, and I get 2x equals negative 3i. Divide by 2 on both sides, and I get x equals negative 3/2 times I. Over here, it's the same thing, but it becomes 2x minus 3i equals 0. So we're going to have the exact same thing, but the positive version, because it's 2x equals positive 3i, and then x equals 3/2 times I. Divide by 2 on both sides. So which one says that? Negative 3/2 I, positive 3/2 I. There we go. If you wanted to try and do this one another way, what it would end up as is if you had 4x squared plus 9 equals 0, you could subtract 9 from both sides, you get 4x squared equals negative 9, and you take the square root, you divide by 4 on both sides, and you get x squared equals negative 9/4. And then you take the square root of both sides, so you have x equals the positive or negative version of the square root of negative 9/4, which I would write as the square root of 9/4 times the square root of negative 1, and x equals, and again we have the positive or negative version, the square root of 9/4 is 3/2, because the square root of 9 is 3 and the square root of 4 is 2. 3/2 times 3/2 is 9/4. So positive or negative 3/2 times the square root of negative 1, which is I, so positive or negative 3/2 times I, same thing. We'll do one more here. Solve the following quadratic equation by completing the square. We haven't done a completing the square. Goody goody. Let's do a completing the square problem. So here we go. X squared minus 9 times x equals 115 divided by 4. Okay, so the goal here is to make it so what we've got is a square on one side of the equation. So what could I add to the left side of the equation that would make this a perfect square? So there's a pattern. Whenever you have a binomial squared, for example, let's say you have x, let's do an easy one. Let's do x plus 4. If we square x plus 4, that's going to be the same as obviously x plus 4 times x plus 4. That's what x plus 4 means, or x plus 4 squared means. So then you have x times x, which is x squared, and then you have x times 4, which is 4x, but then you turn around and do it right over again, 4 times x. So you have x times 4 and 4 times x. So you have 4x and 4x, which is 8x. And then you have 4 times 4, which is 16. So what happens is that whatever this number is, the square root of it is always half of this number. So you can re-engineer that. If I told you I had x squared plus 8x, and I wanted you to do what we call complete the square, you could say, oh, well, x squared plus 8x plus 16 would be equal to 16 if I added 16 on both sides. And now x squared plus 8x plus 16 is actually a square that you could break into x plus 4 squared equals 16. So that's another way to do this problem, is that you could break that up into what would be a square and everything else. Because you take the square root of both sides and you can solve the problem from there. You can keep going. But the bottom line is the pattern that you have to recognize is that if in a square of a binomial, the last term will always have a square root that is half of the middle term. So in other words, when you have ax squared plus bx plus c, in this case, the square root of this is going to be half of whatever this is, if this leading number is 1, I should say. So let's go back over here. Well, first of all, this is negative. Well, let's do a negative one real quick. Let's say I had x minus 7 squared. Well, that turns into x minus 7 times x minus 7. So x times x would be x squared. And then you have negative 7x and negative 7x. So that's negative 14x. And then negative 7 times negative 7 is positive 49. So still, the square root of that is half of this, but the sign dictates what the number is. So what's the square root of 49? Well, it's 7. And since this is negative, negative 7 is what we'd be looking for. So now let's look at this one. I have x squared minus 9x. If I want to complete the square, I want to add something to both sides of the equations that makes the left side the square of two binomials. So again, what's half of 9? It's going to be 4.5 or 9 halves. Well, if that is what we're going to square, then what would that be? What's 9 halves squared? And that would be 81 fourths. So what I'm going to do is I'm going to add 81 fourths to both sides of that equation. Again, because half of 9 is 9 halves, and 9 halves squared is 81 fourths. Just like if I had over here, half of 8 is 4, and 4 squared is 16. That's what I want to add to both sides. Over here, half of negative 14 is negative 7. Negative 7 squared is 49. The last term is going to be half of this squared. So now I have x squared minus 9x plus 81 fourths equals 115 fourths plus 81 fourths. So again, we already have our common denominators there. That's lucky. And you have 196 quarters, and 196 quarters is 49. So here we go. We have x squared minus 9x plus 81 fourths. Again, that is going to be x minus 9 halves squared equals 49. And now we just take the square root of both sides. So I want the positive or negative version. So I have x minus 9 halves is equal to positive or negative 7. And now I add 9 halves to both sides. And I get x equals 9 halves plus or minus 7, which I'm going to write as 14 halves now, because 7 is 14 halves. And we have x equals 9 plus 14 halves, which is 23 halves. And we also have 9 minus 14 halves, which is negative 5 halves. And right here, negative 5 halves and 23 halves. Okay, so feel free to email me with any additional questions, or if you have a very specific problem that you want me to take a look at and help you with and give you hints along the way. Keep working hard, and let me know if you need anything else.